So in the last video, we set up and ran a screening Pew matrix for a new spoon for children with arthrogryposis. Unfortunately, that screening matrix failed and that it didn't identify solutions that could be discarded. There are a number of reasons why screening Pew matrices may fail. One mistake teams make is that they proceed solution by solution when moving through their screening Pew matrix. The proper way to do this is to move through design criteria by design criteria. This allows for less bias when completing the screening Pew matrix. A second reason is that there was considerable subjectivity when going through the screening Pew matrix. This can often happen when there's a champion on your team for one particular solution. Teams that move through subjectively are often pulling the plus, minus, and zero out of the air instead of using data to drive their solution. Now, I would admit that it is hard to do this since some of the solutions are still ill-formed. However, you can work around this by talking through the solutions in details. This can help your team better establish whether plus, minus, zero is a better choice. A third common mistake is that you have ill-defined design criteria. For example, when we considered the idea of lightweight earlier in our screening Pew matrix, it might be vague whether this is the overall device or what is in the hand. Unless your team has discussed through what lightweight means, there can be quite a bit of argument or disagreement about what a plus, minus, or zero might be. So the fourth mistake that can occur is when you make a bad choice for the standard. So you only know that this happens when the standard ends up being considerably better or considerably worse than all of your other proposed design solutions. Now, this is what happened in our own example and is likely where our screening Pew matrix went wrong. This is something you can't always know before you begin, and when you do make the choice of a bad standard, you'll almost certainly have to redo your screening Pew matrix. So let's look more deeply at our screening Pew matrix. Here, the standard solution F is the Winsford feeder, and it's very similar to the Ferris wheel solution H. They're identical in all except for cost, so that their results are very similar. And if you look at all of the other proposed solutions, for example, A, B, and C, what you'll see is that they track identically for time, ease of use, lightweight, and cost. There is some variability for transportation and durability. However, using F as a standard is not able to distinguish between all of these different solutions. So instead of using the Winsford, we're going to select solution C as the standard. The reason we came to this decision is that we talked it over as a team, and we decided that in its ability to deliver food, as well as its size and complexity, solution C was an intermediate solution. So at this point, we're going to go through the screening Pew matrix again, using solution C as the standard. In setting up the screening Pew matrix, the first step is to list the design criteria along the left-hand side of the table. The second step is to list the solution ideas along the top row of the table. The third step is to set a standard. We agreed earlier that we were going to use solution C as our standard. The first thing we'll do here is we'll set the standard C with scores of 0 for all of the design criteria. In the interest of time, we'll look only at the reduction and feeding time. So we'll start by asking the question, how does solution A compare with solution C in terms of time reduction? And if we think about the way that the movements would occur for someone feeding themselves with solution A and solution C, we determined that those were fairly comparable. As a consequence, we scored solution A with a 0. Then we'll move on and ask the question, how does solution B compare with solution C? The time to operate the trigger in solution B, we expect that that will extend the feeding time relative to the standard, and as a result, we're going to give solution B a minus relative to the standard. Continuing, we'll ask the question, how does solution D compare with solution C? With solution D, we expect one motion to get the food from the plate to the mouth. Thus, we predict it will take less time than solution C, our standard. For this reason, we'll give solution D a plus in time. We'll finish filling out the row of time across for the remainder of the solutions, E through J. So your team will continue to fill out the whole chart, going row by row, design criteria by design criteria. It's important that your team move through this in a systematic way, going slowly and with integrity, using numbers to inform decisions. Step 5 will sum the scores to determine the rank of the solutions. Step 6 is to reflect on the results. There are a number of important observations when looking at this updated screening P-matrix. First, there's a much wider range of solutions, ranging from -5 for solution B to +2 for solutions D and J. So with solution C as the standard, we are not seeing the compression that we saw earlier when we had the Winsford feeder as the standard. You'll also note about half of the solutions are ranked above the standard and about half of the solutions are ranked below the standard. Again, this just reinforces that solution C as a standard was a good choice. The second thing we should do is look through the solutions to see if you could combine or improve any concepts. One strategy is to look at the solutions with several pluses and several minuses to see if you can borrow ideas over from a different solution to mitigate the minuses. Let's consider solution E. It has 2 minuses and 3 pluses. So we were able to imagine a solution that combined the right angle idea of solution E with the pull string mechanism of solution A. This resulting solution we're labeling solution AE. Now, if we put AE into our Pew screening matrix and score it, we'll see the following results. Step 7 is to select the concepts to move forward for more evaluation. So first, let's consider the solutions to be thrown out. Solutions A and E were combined, so they can be removed. Solution B scored a -5, so it should definitely be removed. We should also remove solutions F, H, and I because they all have negative values. So now let's consider the solutions that will move on. Here we select our highest ranked solutions. There's solution D, the 4-bar linkage, at a +2. Solution AE, our combined solution, hinge and string, with a +3. Solution G, the bendable spoon, at a +1. Solution J, the ball and socket, at a +2. And solution C, our standard, the barrier support, at a 0. So we finally completed the screening P-matrix. So if it seemed like it took a long time, it's because it did. Going through screening P-matrices can often take a long time if your team does it with integrity. But it's a really important step. In fact, one of the most important steps in the design process, so it is important to slow down and take the time to do it right. So if you recall in our diagram, the process of using a screening P-matrix reduced the number of ideas. However, upon reflection, we actually added an idea, which you can see here in the diagram. At this point, we're ready to move on to a scoring P-matrix to reduce the number of ideas to just 1 or 2. So in summary, we've just completed a screening P-matrix where we reduced a large number of ideas to a few, who we can now bring on to a scoring matrix.